This is problem 10 of the 2023 AIME I, and the problem reads, there exists a unique positive integer a for which the sum u equals sum from n equals 1 to 2023 of the floor of the quantity n squared minus na over 5 is an integer strictly between negative 1,000 and 1,000. For that unique a, find a plus u, noting that the floor of x denotes the greatest integer that is less than or equal to x. All right. This sum seems quite arbitrary at first. Like you look at and you see like a bunch of floors, and like there doesn't seem to be a rhyme or reason to this. And at this point, you might get a little intimidated by the notation. You might give up or something. But this problem turns out to be quite simple. And that's because, well, what does this floor really mean? Well, so let me introduce some notation. If floor of x denotes the greatest integer that's less than or equal to x, why don't I write x minus floor of x equals this little curly brackets x, which I'm going to call the fractional part of x. And I'm calling it the fractional part of x because it denotes, well, the what you really get when you remove everything before the decimal point. For example, if x is equal to 16.2, floor of x is most definitely equal to 16, which means that fractional part of x is equal to 0.2. And similarly, if you have x is equal to 4/3, floor of x is 1 and fractional part is 1/3. And in every case, you see that the fractional part is going to be between 0 and 1. X is in 0 and 1, where the 0 is included and the 1's not included. And you can kind of see that this has the potential to be very useful, because what we can do is we can rewrite this big sum as the sum from n equals 1 to 2023 of quantity n squared minus na over 5 minus the fractional part of n squared minus na over 5. And we can rewrite that as the sum of two sums. Namely, we can rewrite this as the sum from n equals 1 to 2023 of this business n squared minus na over 5 minus the sum from n equals 1 to 2023 of n squared minus na over 5. All we're given is that this thing is between an integer between negative 1,000 and 1,000, but that doesn't really tell us much. It just tells us that it's in some range. So why don't we look at this and look at these two sums and see what we can tell about each of these. So first of all, this sum, this first sum, we can further break into something like the sum of n squared over 5 minus the sum of n times a over 5, where n is from 1 to 2023 in both cases. And we can sort of factor out a 1 over 5 from this one. And we can factor out an a over 5 from this one. So we put the a over 5 on the outside. And now you look and you see, okay, this sum from n equals 1 to 2023 of n squared. We have a formula for that. 1/5 times the quantity 2023 times 2023 plus 1 times 2n plus 1, that's 4,047 over 6. If you don't know the sum of the first n squares formula, it's you can see it sort of down here. And the sum of the first n integers is n times n plus 1 over 2. So in this case, 2023 times 2024 over 2. And we can sort of factor out a few things from both of these in order to write the sum in a little bit of a nicer way. Namely, 2023 times 2024 over 5 times 2. And then we multiply this by 4,047 over 3 minus a. 4,047 over 3, for reference, is it's going to be, well, 1,349. So 1,349 minus a. Okay, so that's what this first sum thingy is. So let me write that over here. 2023 times 2024 over 5 times 2, which is 10 times 1, 3, 4, 9 minus a. And this sum we don't know anything about, but we know that the fractional part of x is in the interval 0 to 1, which means that you're basically adding up 2023 terms that are all between 0 and 1. So we're going to have 0 is less than or equal to this sum, which is going to be less than 2023. And what does that mean? Well, it means that how are we ever going to get this whole thing between negative 1,000 and positive 1,000? Because you look at 2023 times 2024 over 10, and you see something like, well, 2023 times 2024 divided by 10 is going to be something like 2,000 times 200. That is a huge number. It is 400,000 times 1,349 minus a. And then you're subtracting like 2,000 at most, or subtracting 0 or whatever it is. But anyway, this is a humongous number because you're multiplying 400,000 by some integer. It could be positive, negative, or 0. And then you're subtracting like 2,000, which seems like a pretty tiny number in comparison. And my claim is that this guy had better be 0, because if it is not 0, then there's no way this difference is between negative 1,000 and positive 1,000. Okay? So this term is 0, which means that a is 1,349. Okay? But what does that mean? It just means that this guy, the sum from n equals 1 to 2023 is 0. Then all that's really left to do then is to sort of see what u is, because remember we want u. So we know this is 0 and this is something between 0 and 2023. So we got to find this sum in order to be able to find what u is. So to do that, we look at sum from n equals 1 to 2023 of the fractional part of n squared minus 1,349 n over 5. And notice how this guy's an integer. The numerator is an integer. It's going to be a multiple of 5, or it could also not be a multiple of 5. But either way, when you divide it by 5, you're going to get a remainder of 0, 1, 2, 3, or 4, which means that the fractional part of this whole thing is going to be either 0, 1/5, 2/5, 3/5, or 4/5. And this is where we break out some of our so-called modular arithmetic, which is basically what remainder are we leaving. So we have a few cases where n is equal to mod 5. N could be 0, 1, 2, 3, or 4. And if you're not familiar with modular arithmetic, that just means that when you divide n by 5, you get a remainder of 0, 1, 2, 3, or 4. And we can also do some very nice things with modular arithmetic. Like we could take n squared minus 1,349 and what is this when you take it mod 5, when you take its remainder when you divide by 5? Well, notice that when you divide this guy by 5, you might as well like look at this 1,349. I might as well change that into a +1. And the reason is because what you're doing is you're adding 1,350 n. That's always going to be a multiple of 5, so you're not changing the remainder. So what's the remainder when n squared plus n is divided by 5? And you can actually plug in 0, 1, 2, 3, and 4 into this thing and get some valid responses. Like when n is 0 mod 5, n squared plus n is also 0 mod 5. Makes sense. They're both multiples of 5. When n is 1 mod 5, you can actually do 1 squared plus 1 equals 2 mod 5, and that will still work. If you don't believe me, try a few examples out for yourself. Like you can try n equals 6, you could try n equals 11. In all circumstances, when this guy is divided by 5, you're going to get a remainder of 2. When n is 2 mod 5, you get 2 squared plus 2 equals 6. Well, we can write this as being equivalent to 1 mod 5 just because 6 and 1 share the same remainder. When as is 3 mod 5, you can put 3 squared plus 3, which is 12, or 2. And when n equals 4, 4 squared plus 4 is 20, or 0. So you get 0, 2, 1, 2, 0 when n is equal to 0, 1, 2, 3, or 4 mod 5. Okay. So what does this mean? It simply means that when you have something like, okay, let me use an example. N is 1 mod 5. When you plug n into n squared minus 1,349 n over 5, you're going to get like 5 times some number plus, we said n was like 2. If n is 2 mod 5, 5n plus 1 over 5. And when you take the fractional part, you get some integer plus 1 over 5. So this fractional part is 1/5. And similarly, the fractional part for something that's 3 mod 5 is going to be 2/5 because this guy's 2. So this contributes 0 to the sum. This contributes 2/5. This contributes 1/5. This contributes 2/5, and so on. This contributes 0 to the sum, right? And therefore, when you look at this sum, you're just gonna get like something like, well, we start from 1, so 2/5 plus 1/5 plus 2/5 plus 0 plus 0 plus 2/5. And you can keep going on and on and on until you get up to 2023. And what's our final sum going to be for this? Well, you kind of see a cycle every 5, like every 5 ends, it repeats. So you're essentially adding this a bunch of times. And in fact, you're adding this, well, you go from 1 to 2020 because that's the last multiple of 5. You multiply this by 2020 over 5. And then you add your last 3 terms, which is not a full cycle, plus 2/5 plus 1/5 plus 2/5. Now, note that 2/5 plus 1/5 plus 2/5 is just 1. And so you're just 1 times 2020 over 5 plus 1. 2020 over 5 is 404. So 404 plus 1 equals 405. And therefore, u is equal to negative 4 over 405. Finally, a plus u is equal to 1,349 minus 405. And that will give us our answer 944. And we are done. Thanks for watching, and I will see you next time.